Hey everybody, in this video we're going to graph this square root function y equals the negative square root of x plus 1 plus 2. So we've got a lot going on here. Right away as I'm looking at this thing, I'm seeing a couple of key transformations here. I'm seeing something with this negative, something with this plus 1, something with this plus 2. So right off the bat I see that this plus 1 on the inside is going to give me a horizontal shift to the left 1 unit. I'm seeing that this plus 2 on the outside of my radical means that I'm going to have a vertical shift up 2 units since I'm adding 2. And then finally this negative on the outside is going to cause this whole thing to reflect over the x-axis. So all three of these things are happening, or at least changing from the parent function y equals the square root of x. So this is going to look a whole lot different than the parent function here. So let's get started by picking some x values to graph this thing. We're going to set up a table here of xy values. And I'm going to want to pick those good numbers that we've called them for my x values. And just a reminder, our good values or good numbers are the things that are going to make perfect squares underneath my radical. So, 2 is not a perfect square. So I'm thinking, what values of x can I plug in here that would get this whole radical a perfect square? So I want this whole radical to equal 0. I want the whole inside this radical to equal 1. I want it to equal 4 and 9. That's kind of what we're after here. So let's see, if I plug in a negative 1 for this x, I'm going to get a 0. If I plug in a 0 for x, this whole thing will equal 1. If I want this thing to equal 4, it looks like I would have to plug a 3 in for x. And finally, if I want this whole radical to equal 9, I would plug in an 8 here. And it looks like that holds up with our shift left of 1. I've moved this thing from 0 to negative 1. And then next, let's plug in all of these x values to find our y values. So y is going to equal negative, actually, you know what, I'm going to go a little thinner of a pen. Y is going to equal negative the square root of negative 1 plus 1 plus 2. And that's going to equal negative square root of 0 plus 2. Well, this just goes away. So this is going to equal 2. So y equals 2 here. Next, I have y equals the negative square root of 1 plus 1, and hold on, I think I have a little error here. If I plug in a 1, I'm seeing that this is going to be square root of 2. I don't want that thing to be a square root of 2. I want it to be a perfect square. So it looks like I'm going to have to change this to a 0. That's all right. Here we go. We recovered. So if I make this a 0, and then I have to add 2, this is going to be y equals the negative square root of 1 plus 2, which is equal to negative 1 plus 2, which is equal to 1. So there's my 1. Let's see. Next up, let's do the next point. I've got y is equal to the negative square root of 3, using this x value here, 3 plus 1 plus 2. So I have y equals the negative square root of 4 plus 2. Square root of 4 is 2, so this is going to be a negative 2 plus 2, which is equal to 0. Here's my next y value. And finally, let's do the last one. So we have y equals the negative square root of 8 plus 1, all that plus 2. So y is going to equal negative square root of 9 plus 2. Square root of 9 is 3, so this is going to be a negative 3 plus 2, which is equal to negative 1. So here are my 4 points. Let's take each and every one of these things and plot them on my graph. So I've got negative 1, 2, 1, 2, 0, 1, 3, 0, 1, 2, 3, and 8, negative 1. So 3, 4, 5, 6, 7, 8, negative 1. And it looks like my graph is looking something like this. And just as we expect, we had that shift of to the left 1 and up 2, and we had this reflection happening here. So this is all according to plan. Everything looks like it worked out. Last thing I want to do here, though, before we finish is let's state the domain and range for this guy here. So the domain is going to be all of my possible x values, and my x values look like they go for everything from this -1 onward. I have no x values to the left of this. So x is going to be greater than or equal to -1. And finally, my range, that's going to be all of my y values. And here, my y values, they have kind of a ceiling here. I've got nothing, if you can kind of imagine, I've got nothing that goes above this line. No y values here. So everything below this point is going to be in my range. So it looks like y is going to be less than or equal to 2. And here we've successfully graphed this function, stated the domain and range, and we've even described the transformations as well.